Hi, I am Evelyne Gong, and I will be doing number 2 of the Unit 2 FIQ group challenge. So number 2 provides the curve defined by y squared equals x squared, y equals 6 for y is greater than 0. And for 2a, it asks to show that d of y equals d of x equals 2xy over 2y minus x squared. So it is basically asking us to find the derivatives of y squared minus x squared, y equals 6, and to make sure that it equals this answer right here. And to show that, we would take the original equation provided, which is y squared minus x squared y equals 6, and use the derivatives. So it'll be 2y times dy over dx, or in other terms, y prime minus 2x times y plus x squared times dy over dx equals 0. Because for whole numbers, the derivative would be 0. And so now it'll equal 2y times dy over x minus 2xy minus x squared times dy over dx equals 0. Next, we would have to add 2xy to the other side. So it'll be 2y times dy over x minus x squared times dy over dx equals 2xy. And then we would factor out dy over dx. So that will make it equal to dy over dx times 2y minus x squared equals 2xy. Then we would divide 2y minus x squared, and we will get this as the derivative of y squared minus x squared y equals 6. And for 2b, it is asking to write an equation for the line tangent to the curve at the point 1, 3. And to do so, we would use the derivative that we found in part A, which is 2xy over 2y minus x squared, and we would plug in the x and y values with the point given. So it'll be 2 times 1y over 2y minus 1 squared. Because you are seeing y as y, we are plugging in the x value first. And then we will get 2y over 2y minus 1. And finally, we would plug in y, which is 3, and plug it in, which is 2 times 3 over 2 times 3 minus 1. And this gives us the slope of the line tangent that we need to find, which is equal to 6 over 5. Then we would use point slope form, which is y minus y1 equals m times x over x1. And we would use the point given as well, which is 1, 3. So it would be y minus 3 equals 6 over 5 times x minus 1. Or to simplify it or solve it, it'll be y equals 6 over 5x plus 9 over 5. And for 2c, it is asked to show that there is a point P with the x coordinate 0, at which the line tangent to the curve at P is horizontal. Find the y coordinate of P. So in order to do that, we would have to graph the original equation, which is y squared minus x squared y equals 6. And for this, it looks like this. Next, we would use that equation and we would need to solve for y. So it'll be y squared minus 0 squared y equals 6. Because x is 0, it is because that the equation includes y is greater than 0, so we would have to look at where the y value is positive, which is the top graph, which is 0, positive 2.449. So that is why we use 0 for x. So to go back to solving for y, it will be y squared equals 6, and we would need to find the square root of 6, which is y equals positive or negative of the square root of 6. And because it is also, again, asking for y is greater than 0, we would use the positive square root. And next, to check, we would plug in 0, square root of 6 into the derivative that we found in part A. And we would get 0. And for D, it asks to find the value of d squared y over dx squared at the point P found in part C. And so it is asking for the second derivative using point P in part C, which is 0, positive square root of 6. And so the second derivative equation would be the top one right here. And we would need to solve. So we combine like terms, it'll be 4y squared plus 4xy y prime, or dy over dx minus 2x squared y prime minus 2 square y minus 4xy y prime minus 4x squared y over 2y minus x squared times to the power of 2. And previously I said minus 2x squared y prime. It would instead be 2x cubed y prime. So it'll be, when we combine like terms, it will equal to 4y squared minus 2x cubed y prime minus 2x squared y plus 4x squared y over 2y minus x squared to the power of 2. So that would equal negative 2x squared y minus 2x cubed y prime plus 4y squared over 2y minus x squared to the power of 2. And now we would need to plug in x from point P found in part C, which is again 0, positive square root of 6. And that would give us negative 1 times negative 4 over y squared over 4 over y squared, which is essentially negative 1 times negative 1, which is also positive 1. And that would be number 2 of Unit 2 of the FRQ group challenge.